Welcome to this quick revision on Parkinson's disease. Parkinson's disease is a progressive neurodegenerative disorder primarily affecting the nigrostriatal dopaminergic system. Dopamine synthesized in the substantia nigra pars compacta, SNPC, projects to the striatum, comprising the caudate nucleus and putamen. Within the striatum, dopamine binds to excitatory D1 receptors to stimulate movement and inhibitory D2 receptors to prevent the suppression of voluntary motion. Direct versus indirect pathways. Basal ganglia output depends on two balanced pathways. The direct pathway, mediated by D1 receptors, inhibits the internal globus pallidus, GPI, resulting in thalamic disinhibition and promotion of voluntary movement. Conversely, the indirect pathway, mediated by D2 receptors, acts through the external globus pallidus, GPE, and subthalamic nucleus, STN, to excite the GPI. This increases thalamic inhibition to suppress unwanted movement. Dopamine normally excites the direct pathway and inhibits the indirect pathway. Pathophysiology and hallmarks. The core defect in Parkinson's disease is the degeneration of greater than 80% of dopaminergic neurons in the substantia nigra pars compacta. Pathologically, surviving neurons display intracellular inclusions termed Lewy bodies, composed primarily of misfolded alpha-synuclein protein. Mechanistically, dopamine loss causes underactivity of the direct pathway and hyperactivity of the indirect pathway, leading to excessive tonic thalamic inhibition and net hypokinesia. Clinical features, TRAP. Clinical manifestations follow the TRAP acronym. Tremor, a 4 to 6 Hz resting, pill rolling, tremor caused by unstable oscillatory feedback in thalamocortical loops. Rigidity, lead pipe or cogwheel rigidity due to uninhibited alpha motor neuron discharge. Akinesia, bradykinesia, slowness in movement execution resulting from loss of cortical motor drive. Postural instability, impaired writing reflexes causing a festinating, shuffling gait. Therapeutic physiology, pharmacological management relies on restoring dopaminergic drive. Levodopa, L-dopa, crosses the blood-brain barrier via neutral amino acid transporters and is co-administered with carbidopa, a peripheral decarboxylase inhibitor, to prevent systemic breakdown. Dopamine agonists directly stimulate postsynaptic D1 and D2 receptors, while MAO-B inhibitors prevent synaptic degradation. In refractory cases, deep brain stimulation, DBS, targets the subthalamic